Very good morning, students. In the previous class, we have discussed about different types of voids. That is, closed packing in case of crystalline solids. We come across with the different types of packing: one dimension, two dimension, and three dimension packing. And after that, we have discussed about the location of tetrahedral and octahedral voids. Octahedral and tetrahedral voids in different types of structures. So yesterday we have completed about the calculation of the different types of voids. So today we have to discuss about numericals based on the different type of voids. Numericals on voids. Numericals on voids. In this type of numericals, you need to calculate formula for the unit cell. They will mention about the presence of atoms or spheres or the constituent particles. It may be atom or molecule or ion in different position. So based on the position of those atoms or ions or molecules, we need to find out the molecular formula of the compound. Already we have discussed about the calculation of molecular formula of the compound based on the position of the particles at corner or body center, or it may be face center, or it may be edge center. Now the particles or the constituent particles or lattice points may be present at different positions of the voids. Tetrahedral void or octahedral void. Based upon that, we need to find out the total molecular formula of the compound. Some of the numericals are there here. So I'll write down those numericals and we'll find out the molecular formula of those compounds. First one, a solid is made up of two elements. Solid is made up of two elements P and Q. Two elements P and Q. Atoms of Q are in CCP arrangement. While atoms P occupy all the tetrahedral sites. Tetrahedral sites means tetrahedral voids. What is the formula of the compound? What is the formula of the compound? Formula of the compound. One of the simple problem here in this problem, solid is made up of two elements P and Q. P and Q are the elements. Atoms of Q are present in CCP arrangement. CCP means it is cubic closed packing arrangement. That is similar to what the FCC type of crystal. While atoms of P are occupying the tetrahedral sites. P are occupying the corresponding tetrahedral sites. So what is the formula of the compound? If you take the CCP arrangement in CCP structure, that is similar to what FCC structure, Z is equal to 4. Z means what here? Effective atomic number present per unit cell. The value of Z is equal to 4. When the value of Z is equal to 4, what should be the number of octahedral voids? Octahedral void is equal to total number of effective number of atoms. That is equal to number of effective atoms. But tetrahedral voids we have discussed already. It is a double the number of spheres or double the number of octahedral void. The total number of tetrahedral void here is equal to 8. It is on CCP arrangement is going to be given. CCP structure is going to be mentioned here clearly. So value of effective number of atom is equal to 4. then octahedral void is equal to 4, tetrahedral void is equal to how much? It is 8. Next, atoms of Q are in CCP arrangement. Q is equal to CCP. What's the total number of atoms here? Z is equal to 4 means that is equivalent to the atoms of Q. So Q is going to be equal to 4 here. Then what should be the value of P? P occupies all the tetrahedral sites. P is occupying the tetrahedral site. P is equal to how many tetrahedral sites are there? Totally 8 tetrahedral voids are going to be there. This is going to be 8. Therefore, what should be the formula? It is P8Q4. When it is going to be P8Q4, what should be the simplest formula of this corresponding compound? It is referred to be as P2Q. If we take the simplest ratio, 8:4 is nothing but 2:1. So the formula of the compound is going to be what? It is P2Q. P2Q is going to be the simplest formula for the compound for this question. Okay? This is question number 1. Is it clear? Once again, the given structure is going to be CCP structure is mentioned. In case of CCP, which is similar to FCC arrangement, value of effective number of atoms is equal to 4. How it is going to be 4? Once again, I'll explain. 8 into 1 by 8, this is for corners. Plus, how many face centers will be there? 6 into 1 by 2, this is equal to 8 into 1 by 8, this is going to be 1 plus 2 into, this is 3. 1 plus 3 is going to be equal to 4. So, effective number of atoms in CCP or FCC is equal to 4. What will be the effective number of atoms in case of simple Q? It is 1. Effective number of atoms of the value of Z in case of BCC is going to be 2. Already we have discussed about that. So, this is question number 1. Another question, second one. Usually such type of questions may be asked in case of competitive examination. Possibility of asking all these questions in board examination is going to be very, very less. Second question, atoms of element B form HCP lattice and those of elements A occupy two-third of tetrahedral voids. What is the formula of compound? What is the formula of compound? So, this problem is also going to be very similar to the first one. Atoms of element forms HCP, it's not HCP, this is going to be taken as CCP. Atoms of element B form CCP type of lattice, and those of elements A occupy the two-thirds of the tetrahedral voids. So, what's the formula of the compound? Here also, in case of CCP arrangement, already we have mentioned Z is equal to 4. When Z is equal to 4, octahedral void is also equal to 4. Tetrahedral void will be double the number of octahedral voids, or double the number of total spheres. Now here, element B is going to be forming what? CCP lattice. So the value of B is equal to, directly I'll write 4 because it forms the CCP. Total number of atoms in CCP is going to be equal to B atom, that is equivalent to 4. Whereas elements A occupy two-thirds of the tetrahedral voids. A is equivalent to, this is two-thirds of the tetrahedral voids. This is TV. It is equal to two-thirds of the tetrahedral void is going to be, this is 8. What's the value of this one? Two-thirds of the tetrahedral voids means it is equal to 16 by 3. Therefore, the value of A is equal to how much? 16 by 3. Value of B is equal to, this is going to be 4. If you multiply by 3, what's the value? This is going to be A16 and B12. A16 and B12 means what is the simplest ratio of this particular compound? It is A4B3. The simplest formula of the compound is referred to be as A4B3. That is the formula of the compound for this type of arrangement, A4B3. Right? I'll remove the first problem. Simple numericals are going to be there. If you know the position of, if you know the total number of voids, and you can identify the molecular formula of the compound very easily without any difficulties. Okay. Next problem. Number 3. In CCP structure of mixed oxides. The lattice is made up of oxide ions. Next, 1/8 of the tetrahedral voids are occupied by 1/8 of the tetrahedral voids are occupied by divalent ions. That is A+2. While half of the octahedral voids are occupied by trivalent ions. That is B+3. This is a different formula. What is the formula of the oxide? This question has been asked in competitive examinations after giving 4 different options. What is the formula of the respective oxide? Okay. First, what type of arrangement it is? CCP. CCP means Z is equal to 4. That is going to be very clear. Octahedral void is equal to 4. Tetrahedral void is equal to 8. Already we have mentioned about that. This is applicable for what type of arrangement? CCP cubic closed vacuum arrangement. Right. In CCP structure of mixed oxides, lattice is made up of oxide ions. Lattice is made up of oxide ions means that constituent particles in case of CCP arrangement is going to be made up of oxide ions. Therefore, this is O minus 2 is going to be equal to, I'll write here, this is going to be 4. How this O minus 2 is equal to 4? Oxide ions are going to be part of the lattice, so total number of effective number of atoms is equal to 4. So O minus 2 is equal to 4, that is directly. Next one, 1/8 of the tetrahedral voids are occupied by divalent ions. Divalent ions means this is going to be A+2. The value of A+2 is going to be equal to 1/8 of the tetrahedral void. This is 1/8 into tetrahedral void. It is equal to 1/8 into what's the number of tetrahedral void? It is going to be 8. 1/8 of the tetrahedral void is going to be there. So this value is going to be equal to 1. Then what should be the total number of, this is trivalent ions. While half of the octahedral voids are occupied by the trivalent ions. So total number of B+3 trivalent ions, it is half of the total octahedral voids. Okay, this is half of the total octahedral void is equal to 4. So this value is going to be equal to what? That is going to be 2. Therefore, what is the simplest formula of the compound here? Therefore, A value, what's the value of A? This is going to be 1. B is going to be equal to how much? It is going to be 2. This is going to be O4. So AB2O4. This is going to be AB2O4. AB2O4 is the simplest formula of the compound for this type of arrangement. AB2O4. So total number of oxide ions is equal to 4. Total number of cations is going to be equal to 1, and total number of B plus 3, that is plus 2 and plus 3, that is going to be 2. Sometimes the same problem can be defined, can be identified based on the oxidation state. You know that one of the rule in case of oxidation states, total charge carried by the cations is equal to charge carried by the anions. Sum of the oxidation number of all the elements in a neutral compound like this, it is equal to 0. If you take AB2O4, how it is going to be correct based on oxidation state? 4 options will be there. AB2O4, one is going to be AB2O4 is going to be there. Next one is going to be A2BO4 will be there. Next one is going to be A2B2O4 is going to be there. Next one is going to be ABO will be there. So out of these particular compounds, AB2O4 is going to be one of the compound. I will take this one is going to be AB2O4. Out of this one, which option is going to be correct without, if you are not able to understand this one, this is also going to be simplest method, but based on the oxidation state, how to find out the answer. So you know that AB2 charge on A and B is going to be given. What is the charge present on A? Plus 2. Charge present on B is going to be how much? It is going to be plus 3. And charge present on this particular oxides, it is going to be how much? It is minus 2. If I take this is going to be A, this is B, this is going to be O, it is minus 2. B is going to be having plus 3 charge. Charge on the A is going to be plus 2. Then, if you consider the corresponding oxidation state of all the element is going to be correct, let us verify this is going to be 2. AB2O4. AB2, both are going to be same. So this is A2B2O4 will consider. So AB2O4, if you consider this one, AB2 and this is going to be O4. Total charge on cations 2 into plus 3 plus 6 plus 6 plus 2, this is going to be plus 8. And total charge on anions is going to be minus 8. Plus 8 and minus 8, that is going to be equal to 0. Hence, this is the correct formula of the compound based on oxidation state concept. Based on this particular total number of voids percentage occupied by that particular A plus 2 and B plus 3, this is going to be the AB2O4, and based on this particular oxidation state. If you take A2BO4, why it is going to be considered as wrong? Charge on A is going to be plus 2, charge on B is going to be plus 3, charge on oxygen is going to be minus 2. What is the total charge of cation? 2 into plus 2 plus 4 plus 4 plus 3, it is going to be plus 7, and 4 into minus 2, it is going to be minus 8. Plus 7 and minus 8, it is not equal to 0, so this is going to be the incorrect answer. So in that way, by using elimination method also it is possible to find out answer for such type of numericals. So the correct answer is of this is going to be AB2O4. AB2O4. Try to understand that problem. So they have given oxide is going to be forming the CC lattice. Once again, if you want, I'll explain. Once this is going to be O minus, so this is going to be very clear. Already I mentioned in previous problem also. How O minus is going to be equal to 4 means I have mentioned clearly. The lattice is made up of oxide ions. So total number of effective number of atoms is equal to total number of oxide ions. A plus 2 is going to be there. This is going to be A plus 2. 1/8 of the tetrahedral void. 1/8 of the tetrahedral void is occupied by this particular A plus 2. 1/8 into 8. 8 is the total number of tetrahedral voids. Next one, B plus 3. What's that? B plus 3 is going to be mentioned here. Half of the octahedral voids are occupied by the trivalent ions. It is half of the octahedral void. Total number of octahedral void is equal to 4. So it is going to be 2. Hence the simplest formula of the compound is said to be how much? AB2O4. Right? Next one, number 4. A solid is made up of two elements X and Y. Atoms X are in FCC arrangement. and y atoms occupy all the octahedral voids and alternate tetrahedral sites. Sites, voids, both are same. Sites. What is the formula? What is the formula of the compound? What is the formula of the compound? Here I am taking different type of problems. Only I am not changing the values. The particular concept is going to be different. What type of arrangement is going to be given first here? It is made up of two elements X and Y. Atoms X are present in FCC arrangement. For FCC type of solid, what's the value of Z? It is equal to 4. 8 into 1 by plus 6 into 1 by 2. That is equivalent to 4. How many number of octahedral voids? That is equivalent to number of spheres. And number of tetrahedral void, if they double the number of spheres, this is going to be 8, which is very similar to CCP type of arrangement. X are present in FCC arrangement, so value of X is equal to how much I should write? 4. X are present in case of FCC arrangement. Y atoms are present. Y atoms occupy the octahedral voids. Octahedral voids and alternate tetrahedral sites. Okay. Y value is going to be equivalent to what? How much is going to be considered for? This is Y. Y atoms are occupying all the octahedral voids, plus and alternate tetrahedral sites. This is alternate tetrahedral voids. This is equivalent to how many octahedral voids are going to be present here? This is equivalent to 4. What is the alternate tetrahedral void? Total number of voids in case of tetrahedral void in case of FCC arrangement is equal to 8. Yesterday we have discussed. Now here it is going to be given that alternate tetrahedral voids. If you take alternate tetrahedral voids, this is going to be equal to 4. One living one. So total number of voids, this is going to be octahedral, this is going to be alternate tetrahedral voids. So total number of atoms of Y is going to be equal to 8. So this is going to be X4 and Y8. This is going to be very clear. X4 Y8 means this particular formula is going to be XY2 in a simplest ratio. XY2 is going to be the formula of the compound here. This is going to be clear. For FCC, Z is equal to 4, effective number of atoms. This will not change under any condition. Octahedral void, that is equivalent to total number of effective number of atoms. Tetrahedral void will be the what? Double the total number of atoms. X is going to be equal to 4. Why I have taken? Because atoms of X are going to be in FCC arrangement, that is equal to 4. Y is going to be nothing but it is occupying all the octahedral voids. How many octahedral voids are going to be there? 4. And alternate tetrahedral sites. Total number of tetrahedral voids are going to be 8. If you take alternate tetrahedral void, that is also equal to 4. 4 plus 4 is going to be equal to 8. X4 and Y8 is going to be there. So simplest ratio if you take, it is going to be XY2. That is the simplest formula of the compound. Hope you are all getting these numericals without any difficulties. We'll go to next problem. Number 5. A compound is formed by two elements X and Y. atoms of element Y, atoms of element Y, this is going to be acting as anions, negatively charged anions. Make CCP and those of the element X as cations. This is acting as cations. Occupy all the octahedral voids. Then what is the formula of the compound? What is the formula of the compound? Simple problem. Right. First one, what type of arrangement it is? CCP. For CCP, Z is equal to 4, octahedral void is 4, tetrahedral void is equal to 8. That you have to recall compulsorily. Atoms of element Y, that is going to be anion. This is going to be Y. This one forms CCP. When it forms CCP, how many atoms of Y should be written? It's 4. Because it is forming CCP, what's the total number of atoms in CCP? That is equal to 4, effective number of atoms. And those of the element X, that is going to be forming cations. Afterwards you can write the charts, no problem. Cations is going to be there. It is occupying all the octahedral voids. What's the total number of octahedral void? That is equal to 4. Therefore, what is the formula? This is going to be X4, Y4, or we can write the simplest formula of the compound is XY. X is going to be occupying all the different types of octahedral voids and Y is going to be forming the CCP arrangement. So, total number of atoms, total number of ions of Y is equal to 4, total number of ions of X is also equal to 4. Then the simplest formula of the compound is which one? That is going to be XY. One cation of X and one anion of what? That is Y. That is the simplest formula of the compound. Next, same type of numericals will be there in examination. Next one, number 6th one. Number 6. A compound is formed by two elements. A compound is formed by two elements M and N. The element N forms CCP and M atom occupy one third of the tetrahedral voids. What is the formula of the compound? What is the formula of the compound? It is also simple problem. Formula of the compound. Here, a compound is formed by two elements M and N. Element N forms CCP. Again, CCP is going to be mentioned. For CCP, Z is equal to 4. Octahedral void is equal to 4. Tetrahedral void is equal to 8. Element N is going to be forming what type of arrangement? CCP arrangement. Therefore, N is equal to directly I'll write 4. it forms CCP arrangement. What is the total number of atoms in CCP? That is equal to 4. And M atom occupy 1/3 of the tetrahedral void. M is going to be equal to, this is 1/3 of the tetrahedral void. How many tetrahedral voids are present here? This is going to be 8 tetrahedral voids are present. 8 tetrahedral voids are going to be present. So the total value of this one is going to be equal to 8 by 3. So M 8 by 3 and N is going to be 4. To take the simplest value, it should be multiplied by 4. This is multiplied by 3. This is going to be M8 and N12 will be there. M8 and N12 means simplest ratio if you consider. This is 4 2s are 8, 4 3s are 12. It is going to be M2 N3. The simplest formula of the compound is going to be M2 N3 for that numerical. M2 N3, right? Everything I have mentioned clearly without any doubt. So M is going to be occupying what? 1/3 of the tetrahedral void. 1/3 of the tetrahedral void means 1/3 into 8 because total number of tetrahedral void is 8. It is 8 by 3. And N is occupying the CC arrangement, that is going to be 4. If you take the simplest ratio, the formula of the compound is what? M2 N3. Okay. Next one. Number 7. In a crystalline solid, anions Y are arranged in CCP arrangement. Cations X are equally distributed between octahedral and tetrahedral voids. If all the octahedral voids are occupied, what is the formula of the solid? Take 1 minute time and try to find out the answer for this particular numerical. What is the total formula for this particular compound? Find out first. Make it fast. What is the formula of the compound? Option may be XY, X2Y, XY2, XY3. What is the correct answer for this numerical? In a crystalline solid, anions Y are arranged in CC arrangement. Cations X are equally distributed between octahedral and tetrahedral voids. If all the octahedral voids are occupied, then what is the formula of this solid? Total formula of this solid. Make it fast. Try to find out the answer. XY, X2Y, or XY2, or XY3. XY3. Here. Probably got the answer. In a crystalline solid, anions Y are arranged in CCP arrangement. CCP is going to be given here. For CCP type of arrangement, the value of Z is going to be equal to 4, octahedral void is equal to 4, tetrahedral void is equal to 8. Right? Next one, total number of Y is going to be forming CCP arrangement. CCP arrangement, the value of Y is equal to 4 directly. And cations X are equally distributed. Cations X are equally distributed between octahedral and tetrahedral voids. But one more sentence is going to be given here. If all the octahedral voids are occupied, this is occupying octahedral voids as well as the corresponding tetrahedral voids equally. And one more sentence is going to be mentioned that if all the octahedral voids are going to be occupied, all the octahedral voids means totally how many octahedral voids are going to be there? That is equivalent to 4. Here I will write 4. Equally distributed means total number of tetrahedral voids is going to be equal to 8. Here it is not mentioned that all the tetrahedral voids are going to be occupied by that particular ion. Only it is going to be given that if all the octahedral voids are going to be occupied, for that I have mentioned this is going to be 4. When it is given that equally distributed, for equal distribution, total number of voids, tetrahedral void is going to be equal to 8. In that one, I have to go with the half of the tetrahedral voids because it is equally distributed is going to be given. Suppose if this sentence is not mentioned, if this particular sentence is not mentioned, then total number of octahedral void will be 2 and tetrahedral void is going to be equal to 4. But here I have taken this one as 4 because all the octahedral voids are going to be occupied is going to be mentioned. Hence, this is going to be 4. 4 plus 4 that is going to be equal to 8. Therefore, X8 and Y4. X8 and Y4 means what's the formula of this compound? It is X2Y. X2Y is going to be the correct answer and second option is going to be correct for this numerical. Question number 7, answer is going to be X2Y. Clear? Without going for the option, you need to read, you need to concentrate on the problem and condition what they have mentioned. Clear? Otherwise, you may get wrong answer. Okay? This is question number 7. Next one, 8th one. Question number 8. In a solid, oxide ions are arranged. Oxide ions are arranged. Oxide ions are arranged in CCP. Oxide ions are arranged in CCP. Okay. Then 1/6 of tetrahedral voids. 1/6 of tetrahedral voids are occupied by the cations A. By the cations A. And 1/3 of the octahedral voids. 1/3 of the octahedral voids. Octahedral voids are occupied by cation B. Cation B. Okay. Then what is the formula of the compound? What is the formula of the compound? Formula of the compound. Simple. To find out the total formula of the compound, in a solid, oxide ions are arranged in CCP arrangement. 1/6 of the tetrahedral voids are occupied by the cations A. Tetrahedral voids are occupied by the cation A. And 1/3 of the octahedral voids are occupied by the cation B. Okay. Then what is the formula of the compound? Okay. What type of arrangement is going to be given? For CCP type of arrangement, Z is equal to 4. octahedral void is equal to 4, tetrahedral void is equal to 8. Okay. What is the position of the oxide ions? Oxide ions are present in CCP arrangement, so oxidation is going to be equal to R. O minus we can write, makes no problem. O minus ion is going to be equal to how much? That is going to be 4. CCP arrangement, it is going to be mentioned, that is going to be 4. Then if you go with another one, that is going to be 1/6 of the tetrahedral voids are occupied by the cation A. What is the value of A? It is 1/6 of the tetrahedral voids. 1/6 of the tetrahedral void. 1/6 into total number of tetrahedral void is going to be equal to 8. This is going to be 1/6 into 8. It is going to be 4/3. This value is going to be equal to 4/3. Then what is the position of the B? 1/3 of the octahedral voids are occupied by the cation B. This is B is equal to, it is 1/3 of the octahedral void. It is 1/3 into, this is going to be 4. Why it is going to be 4? It is octahedral void, that is equivalent to 4. Then what is the simplest formula of the compound? This is A value is going to be 4/3. B value is also going to be, this is equivalent to 4/3. B is also found to be 4/3 and oxidation is equal to 4. If you take the simplest ratio, you have to multiply by 3. This is going to be A4, this is going to be B4, this is going to be 12. Then what is the simplest ratio formula? It is going to be 4:4:12 means it is 1:1:3. Then the formula of the compound is going to be what? AbO3. Total formula of that compound is going to be AbO3. So this is 1/6 of the tetrahedral voids are occupied by the cations A, so it is going to be 4/3, and this is going to be total cation is going to be B, valence is not mentioned, so this is going to be equal to 4/3, and the simplest formula of the compound A 4/3, B 4/3 is going to be there, oxidation is going to be equal to 4. And to take the simplest ratio, so it should be multiplied by 4. It is A4, B4, O12. Then the formula of the compound is what? AbO3 formula. AbO3. Okay. Next one problem. Somewhat typical problem. It's not so simple. Typical problem is going to be there. Try to identify answer for the next one. This is question number 9. Question number 9. Okay. The mineral spinal has the molecular formula MgAl2O4. MgAl2O4, it is known as spinal. In this oxide ions, in this structure, oxide ions are present in CCP arrangement. Oxide ions are present in CCP arrangement. Mg plus 2 magnesium ions. Mg plus 2 ions occupy tetrahedral voids. While Al plus 3 ions occupy octahedral voids. Then calculate percentage of first one, tetrahedral void occupied by occupied by Mg plus 2 ions. Mg plus 2 ions. Second one, percentage of octahedral void occupied by Al plus 3 ions. Occupied by Al plus 3 ions. Read the problem once and try to find out the percentage of tetrahedral void occupied by the Mg plus 2, because Mg plus 2 is occupying the tetrahedral void, and total percentage of octahedral void occupied by the Al plus 3 ions. What is the simplest formula of this spinal? That is MgAl2O4. What's the name of this particular formula? It is spinal. The mineral spinal has the molecular formula MgAl2O4. In this, oxide ions are present in CCP arrangement. Mg plus 2 ions occupy the tetrahedral voids, while Al plus 3 ions occupy the octahedral voids. Then calculate the percentage of tetrahedral void occupied by Mg plus 2 ions and percentage of octahedral void occupied by the Al plus 3 ions. Try to find out answer for this one. What is the percentage occupied by Mg plus 2 and percentage of Al plus 3, which is occupying octahedral voids? Make it fast. Make it fast. Total percentage of octahedral void and tetrahedral void. It is going to be mentioned that CCP arrangement is going to be CCP arrangement. For CCP arrangement, value of Z is equal to 4. Octahedral void is also equivalent to 4. Tetrahedral void is equivalent to 8. Right? That is very simple. And in this, oxide ions are present in CCP arrangement. Oxygen are present in CCP arrangement, means total number of spheres in CCP arrangement is equal to 4. Next one, Mg plus 2 ions. Mg plus 2 occupy the tetrahedral voids. Mg plus 2 occupy the tetrahedral void. Here this is O minus 2. It is Mg plus 2. What's the total number of tetrahedral void? Tetrahedral void is equal to 8. Fine. And Al plus 3 ions are occupying what? Octahedral voids. Al plus 3 ions are occupying octahedral voids. That is, octahedral voids is going to be equal to how much? It is going to be 4. Here they are not asking the simplest formula. Anyway, simplest formula is going to be mentioned here. They are asking you what is the total percentage of tetrahedral void occupied by magnesium ions and total percentage of octahedral void occupied by the aluminium ions. So first one, percentage of tetrahedral void occupied by which one? Mg plus 2. Mg plus 2 ions is equivalent to what? According to this formula, total number of octahedral voids, total number of tetrahedral voids. Tetrahedral void is going to be mentioned that it is equivalent to 8. Mg plus 2 is going to be occupying those corresponding 8 particular tetrahedral voids. But in this formula, how many magnesium ions are present? Only one magnesium is present. When the only one magnesium ion is present, out of 8 tetrahedral voids, only one tetrahedral void is occupied by the magnesium. So this is 1 by 8 into this one is going to be 100. So 1 by 8 into 100 is going to be equivalent to how much it is? It is 100 by 8 means this value is going to be roughly equivalent to how much? It is 12.5%. This is going to be how much? 12.5%. Why I wrote it is 1 by 8? Total number of voids are going to be how many? 8 are there. Whether all the 8 tetrahedral voids are occupied by the corresponding magnesium? No. Only according to the formula, only one magnesium ion is going to be present. Out of 8 tetrahedral void, only one magnesium occupies one tetrahedral void. So 1 by 8 into 100, that is going to be equal to how much? 12.5%. Second one, percentage of octahedral void occupied by which ion? Octahedral void occupied by Al plus 3 ions. Al plus 3 ions. Hope you are getting this one. Percentage of octahedral void occupied by the aluminium ions. What is the total number of octahedral voids? Total number of octahedral void is going to be equivalent to 4. Out of 4 octahedral voids, how many octahedral voids are occupied by the aluminium ions? According to the formula, 2 aluminium ions are going to be present. When 2 aluminium ions are present, this is 2 by 4. Is it clear? How it is 2 by 4? 2 by 4, total number of aluminium ions are going to be 2. Total number of possible octahedral void is going to be 4. So 2 by 4 into 100. 2 by 4 into 100 means it is going to be 50%. Totally 12.5% of the tetrahedral voids are occupied by the magnesium ions and 50% of the octahedral voids are occupied by which one? That is going to be aluminium ions. So this is the percentage of what tetrahedral void occupied by the magnesium, that is going to be 12.5%, and percentage of this octahedral void occupied by the aluminium ions is going to be how much? It is going to be 50%. So this is the answer for this question. Clear? Question number 9. Next 10th one. Another simple problem to find out the molecular formula of the compound. Molecular formula of the compound. Number 10. In a crystalline solid, anions C are arranged. Anions C are arranged in CCP. Cations A occupy 50% of tetrahedral voids and cations B occupy 50% of octahedral voids. What is the formula of solid? Simple problem. What is the formula of the solid? In a crystalline solid, anions C are arranged in CCP. Directly I am writing here. C is equal to 4. Anions C are present in CCP. Total number of spheres in case of CCP is equal to 4. Cations A occupy 50% of tetrahedral voids. A is occupying 50% of tetrahedral void. 50% means it is half of the tetrahedral void. It is 1 by 2 into 8. This is equivalent to 4. And what is the position of the B? B also occupies 50% of the octahedral voids. It is 1 by 2 into 4. 8 is the total number of tetrahedral voids. 4 is the total number of octahedral voids. For both the cases, it is going to be given as 50%. This is going to be equal to 2. Therefore, the simplest formula, it is A4, then B2, then it is going to be C4, or the simplest ratio. If you consider, this is going to be A to B, C2. 4 is to 2 is to 4 is nothing but 2 is to 1 is to 2. So the formula of the respective compound is going to be A to B, C2. This is the simplest formula of the compound. So these are some of the numericals based on calculation of formula of the unit cell are such type of percentage of the total voids, octahedral voids as well as tetrahedral voids based on the different type of voids. So based upon this one, after complete discussion based upon this numerical, you can calculate, you can get the answer for any type of problem if it is based on the total voids, that is octahedral void or it is going to be tetrahedral void. So after completion of this particular percentage of this void as well as total formula of the unit cell consisting of different cations as well as anions. Next one we have to go with another very important concept is going to be simple introduction about this one, that is going to be called as the packing efficiency. It is going to be called as packing efficiency. Very important concept here. And in board examination, one question will be there compulsorily for 3 marks. That is, explain the packing efficiency in case of simple cube or body centered cube or face centered cube. One question will be there for 3 marks. And based on the values, based on the relationship between the R as well as edge length. R is going to be called as the radius of the sphere and A is going to be commonly called as the edge length of the unit cell. We will come across with some of the relationship between A as well as R in case of simple cube, then body centered cube, and last one is going to be face centered cube. We have to calculate the packing efficiency in all the 3 different types of unit cell, that is simple cubic unit cell, body centered cubic unit cell and face centered cubic unit cell. What is the meaning of packing efficiency? Packing efficiency is nothing but it is a percentage of the total volume of the unit cell occupied by the different type of spheres. Suppose if you consider this particular one unit cell here, if you consider one unit cell, you can consider this one is going to be a simple cubic unit cell. It is going to be called as primitive unit cell. In this primitive unit cell, 8 different type of spheres are going to be present at the corner like this. 8 particles are going to be present at the corner. When 8 particles are going to be present at the corner, complete 100% of the volume of the unit cell is not occupied by the spheres. Since it is a sphere, some amount of empty space is going to be created here. So, how much percentage of the unit cell is occupied by these corresponding spheres is going to be called as packing efficiency. Suppose if you come across here in case of simple cubic unit cell, the value of packing efficiency is approximately 52.4% will be there. It means that 52.4% of the total volume of the unit cell is occupied by the corresponding spheres, and remaining percent 100 minus 52.4, whatever percentage is going to be left out, whatever the value is going to be obtained, that is going to be commonly known as the void or the empty space. Void or the empty space. So greater is the value of packing efficiency, greater is the stability of the solid. As the number of particles goes on increases, in simple cube only 8 particles are present at the corner. In case of simple cube, only 8 particles are at corner. In case of BCC, 8 particles at the corner and 1 particle is going to be at the body center. Totally it is going to be equal to 9. In case of FCC arrangement, 8 are present at the corner plus 6 are present at the face center. Totally it is equal to 14. As we are going from simple cube to body center to face center, total number of particles, here it is going to be 8, here it is 9, here it is going to be 14. Then the percentage unit cell occupied by the spheres also goes on increases. Naturally, this is going to be having lowest packing efficiency and this is going to be having highest packing efficiency. So that packing efficiency we need to discuss about that one. Here we come across with the relation between A and corresponding R. A is commonly called as the edge length of the unit cell, where R is going to be called as the radius of the sphere. The relation between A and R is also important. So based on this particular relationship of especially BCC, one question was there in last NEET examination. that is 2020 NEET exam. So for BCC value, this is going to be equal to 4R is equal to root 3 is going to be there. Based on this simple relationship, one numerical was going to be there without any calculation. If you remember this formula, you can get the answer very easily. So here we come across with the relationship between A and R, total packing efficiency of the corresponding solid. After that, we have to calculate about density of the solid. Density of the solid by using another particular expression, another formula is going to be there to calculate density of the unit cell, where either density or molecular mass or the value of edge length, they may ask to calculate any one of the parameter. So first, we have to discuss about the packing efficiency. You got the preliminary information regarding this packing efficiency. Packing efficiency is nothing but the percentage of the corresponding unit cell occupied by the different type of spheres. That is going to be commonly known as packing efficiency. For any type of solid, packing efficiency is not equivalent to 100%, because in all the unit cell, the constituent particles are found to be spheres. When you add the spheres in a particular cubic closed structure or any particular structure, so all these spheres are not occupying the 100% of the volume of the corresponding unit cell. So packing efficiency is not equivalent to what 100% in any of the unit cell. Because of that reason, so different type of unit cells are having different value of packing efficiency. First, we have to discuss about the packing efficiency, and afterwards some of the numerical to calculate the density of the solid or edge length of the solid. So tomorrow we'll start with what packing efficiency in case of solids. Okay. Packing efficiency in case of different types of solids. Very important concept. Don't miss tomorrow's class. Packing efficiency. Okay, tomorrow we'll be starting with packing efficiency. Thank you.